would like to introduce the next speaker, Allison. Allison is the Associate Director for Vector Control at the University of California, San Francisco, Malaria Elimination Initiative. For the last 10 years, she has been working with national malaria programs on malaria elimination. Her team focuses on two areas: first, entomological surveillance, and second, innovative vector control tool. Our presentation today will focus on an expanded vector control toolbox to reduce residual malaria transmission. Thank you very much. Allison.
Good morning. Thanks, April and France, for organizing this symposium. So I have the pleasure to speak with you all today about our work looking at an expanded toolbox of vector control tools that could be used to control and target residual malaria transmission. So the way I like to conceptualize the problem is, so let's say our question is, why is malaria plateauing in a certain area or potentially increasing in a certain area? So I think we could explain it in a couple of ways. One, potentially due to operational inefficiencies. So this could be low coverage, stockouts of ACTs, and maybe one response to that is quality improvement, improving coverage, improving stocks. Another way to explain why transmission might be plateauing, persisting, potentially increasing in a certain site might be because insecticide resistance, and therefore we lose the efficacy of our vector control tools. And so a response to that might be resistance prevention or management, introducing new vector control tools, new nets, new IRS, new active ingredients to counter resistance. And another explanation, which our other presenters just explored, is potentially there's residual malaria transmission, this transmission that's persisting despite the use of existing vector control tools, and then potentially to respond to this, we need supplemental interventions. These could be drug-based strategies, potentially focal mass drug administration, et cetera. It could also be vector control supplemental interventions. So this is sort of the conceptual framework that I like to think of, and I'll focus on the vector control toolbox that might exist to counter and respond to some of the gaps in protection that were identified by some of the other speakers in our symposium. So just to note that probably at any given site there's a combination of drivers of transmission, and it's never just one. So when we think about the opportunity to exploit mosquito life cycles, we're really in some ways limiting ourselves by focusing on the household. As April noted in her opening remarks, that ITNs and IRS have had a tremendous impact on malaria transmission with that focus on indoor biting. But in fact, there's a much more complex mosquito life cycle that we may not fully be exploiting. And at every stage, there's a potential new tool out there that could exploit that particular behavior, like, for example, zoophilic behaviors of vectors, and this is something Camis pointed to in his presentation, seeking blood meals from non-human hosts. Sugar feeding. All mosquitoes feed on sugar as a source of energy, and potentially that's a space that we could explore to control more vectors. So I think this is what we think about when introducing a broader set of tools. So exploring the toolbox, the attractive toxic sugar baits, which, as I just mentioned, exploit the sugar feeding behavior of mosquitoes. New tools out there that potentially target livestock. So this could be antiparasitics, systemic insecticides that actually kill vectors that feed on livestock. Other tools to explore that have to do with housing. Various studies looking at screening, at adding eave tubes to the eaves of, closing eaves and adding eave tubes to the households. Larviciding. Other tools like spatial repellents. This is mosquito coil, but there's new tools coming online that are passively emanating, so it doesn't require a match or a battery or It just emanates volatile insecticides that can protect within a given radius. Space spray is being explored as a malaria tool, prevention tool, for example, through a study that we've been involved with in Burkina Faso, looking at if space spray is timed at the right time, could it be a tool for Anopheles prevention? And I think there's a growing need to demonstrate evidence in that area. Looking at drones for larviciding, there's been a few presentations this week on the opportunity for aerial delivery of insecticide, not just mapping. And then genetic control of mosquito populations. So those are some of the new tools in an ever-expanding toolbox. And what we see is that this toolbox has actually never been so expansive. So I think there's a lot of opportunity for us. So one piece of work that we've done over the last couple of years is to conduct a systematic literature review of the vector control toolbox, excluding IRS and ITN. So we were really focused on all the other tools I just explained. So we wanted to systematically collect and collate evidence on 21 vector control tools, establish a level of evidence by study design, and stratify by outcome when it was possible. It was a very heterogeneous set of studies. And we wanted to, through this work, identify gaps and opportunities for research to expand the evidence base on the vector control toolbox. So the inclusion criteria was based on study designs, as I mentioned. We included systematic literature reviews that have already been conducted, experimental studies, stratified by phase of study, and operational studies as well were included. Outcomes, we looked at both epidemiological outcomes as well as secondary entomological outcomes. The team screened almost 18,000 abstracts. This is quite a feat, and came out with 155 eligible studies for inclusion in the qualitative synthesis. So this work was led by Yasmin Williams and Lucy Tusting on our team, and these were the list of tools that were explored in this systematic literature review. And what we found is that only 7 of these tools had gone through a phase 3 evaluation as of September 15th, which was the end date for our screening. And as we know, phase 3 evaluations are the burden of proof required by the WHO Vector Control Advisory Group, the VCAG, and policymaking bodies for new vector control tools. So the 7 tools listed toward the top had been through these evaluations, and that includes LSM, larval source management, topical repellents, spatial repellents, insecticide-treated clothing, hammocks, insecticide-treated hammocks, mosquito-proofed housing, namely house screening in that trial, and also insecticide-treated livestock. We do know since we did that review, there are additional phase 3 trials in progress, and this comes from the VCAG review process. So there's additional trials on spatial repellents, attractive toxic sugar baits, push-pull systems, eave tubes, as well as new nets, dual active ingredient insecticide nets, as well as PBO nets. So to supplement our systematic literature review, we also conducted a survey of experts and implementers, including malaria programs, on the toolbox to get a sense of what they thought of the operational feasibility of implementing these tools, of the time to market for these tools. And we'd like to do this again to a much broader pool. I think our sample here is quite small, but we did receive some really interesting insights. So there are a number of tools, those really on the left side of your screen, where experts and implementers felt that these were sort of the low-hanging fruit of vector control. So these include environmental management, larviciding, mosquito-proofed housing. So this does not indicate any sort of level of effectiveness. This is purely what experts thought was the level of available evidence on these tools and operational feasibility. So I think one point that's interesting from this slide is if you hone in on the operational readiness, so those are the grayish triangles, that operational readiness for the bulk of these tools was kind of seen as we're halfway ready, so we're at the midpoint. And I think the message there is that a lot of these new tools will require more operational capacity than potentially what a lot of countries have right now, and to scale up that operational capacity for robust implementation might be needed. So out of all of this work, the systematic literature review, the preliminary survey of experts, we have developed what we think is a short list of vector control tools that within the next 1, 2, 3 years could be integrated more and more in malaria programs. So some of these are currently in evaluations. As we look at the mosquito behaviors that it exploits at the different stages of the mosquito life cycle, it's quite a diverse set of tools that we might have access to in the short term. And as you see in the second to, let's see, this column right here, we did survey malaria programs, and there's a number of tools where malaria programs expressed interest in implementing. So a couple of the presenters, and John in his last slide suggested as a next step of modeling, and we did this as part of our project. This was work led by Samson Kiwari at Ifakar Health Institute and other colleagues who developed the vector control optimization model that attempts to look at these various tools in combination, modeled in different transmission settings, to look at the impact. And I think that this is a great way to estimate the potential impact for these tools and feed into empirical studies to improve the evidence base across the toolbox. So potentially one way to move forward is through a learning by doing approach, where first of all, not just looking at vector control approach, but also drug-based strategies integrated into a surveillance system, where there is ongoing evidence being generated, and I would say on the bulk of these tools, we still don't have full confidence in most of them about the appropriate transmission ecologies, the way they interact with other vector control tools, but that potentially some of these lower-hanging fruit in the vector control toolbox could be evaluated in a learning by doing approach, where it's iterative, where we're planning based on the transmission ecology that our previous speakers described, understanding human behavior, how it links with vector behavior. So this is the trying of a new tool with rigorous monitoring and evaluation, and then findings incorporated into a program and iterated again. And this might be a way forward for some of these low-hanging fruit. So thank you very much.
Great, thank you, Allison.